At first glance, the packaging of the lid boss, well, it looks pretty simple. Some standard cardboard sheets and relatively prismatic geometry. But when I talked to Mark and Jesse at Center for Advanced Design, I learned that packaging is another part of the product development that basically merits its own sub-projects.
We did the prototypes of the packaging. We had a cardboard house that did it for us, made the samples for us, and then we started shipping the machines around to see if it's going to live. Because there's some of the components in there that if it gets jarred too hard or something like that, it will throw the whole machine off. It has the ability to. We then sent the machine off to a testing facility that is kind of independent UPS testing facility, and also one from FedEx. And they would run through a whole gamut of tests, including the last one, which was, I think was like a 12-foot or 13-foot drop onto one side, and to see if your packaging is actually going to live. So we got 5 stars on the testing, so that we kind of knew we're probably good there. And then the thing was like, oh man, did we overpackage this thing now? Are we spending way too much money on packaging and stuff like that?
Well, in the very beginning too, we found out pretty quickly. We got into some of the test markets with some of the fast food restaurants, some of the at the corporate level.
Mm-hmm.
And the first ones we sent over had styrofoam packaging inside. So that was like the first thing they noticed right away. You can't have any styrofoam in there. So then we had to kind of spin pretty quick and come up with a plan there to keep that ball rolling.
That's great that their prototype packaging got a 5-star result. But was it over-designed? How much of the expensive physical testing could have been done virtually? And what insights can we extract from simulation? And how will they make sure that our customers receive an intact shipment no matter where they are around the globe? Eric has a lot to unpack for this next task.
Eric has an initial packaging design mocked up in SolidWorks, combining the use of cardboard and foam. From his previous experience, Eric thinks that this will be more than sufficient. However, he needs to do some testing to validate the final design. And since he has a limited budget and not much time for physical testing, Eric contracts Adam Analyst, who is more familiar with simulating the real-world performance of packaging. With Adam as a member of the platform, Eric adds him to the task so that he can easily find the design and know where to share the simulation results. After logging in, Adam also gains access to the team's dashboard, where he can quickly find the assigned task, review the details of the drop test, and open the model. For now, he will focus on one drop onto the bottom face of the package. In order to define the initial position, Adam creates a new assembly, models the floor, inserts Eric's SolidWorks model, and orients it to the desired position. Meshing is one of the most important steps in performing an accurate simulation. And with a mix of solids, surfaces, and thin-walled components, it isn't always a trivial task. He begins with the automated method to create a mid-surface mesh of the box. After specifying the options and clicking run, the app automatically creates an associated surface body, shell section, and mesh. Adam also sees that the material definition from SolidWorks is maintained, eliminating the need to reapply the material for the simulation. Adam moves on to create this structural scenario, but what about meshing the other components? Not to worry. After initializing the simulation, Adam leverages the built-in assistant throughout the next steps. The assistant helps make sure Adam doesn't miss anything from setup to results. For the setup, Adam has access to a wide range of procedures, all powered by Abacus. He defines the explicit method, which is well suited for the high-speed, dynamic behavior of his test. With the Contributing Shapes Manager, Adam easily adds all the components in the model to the simulation, and because of the mid-surface of the box that was created earlier, he excludes the solid representation. He hides the mesh and shows only the contributing shapes to visually confirm his selection. To define the material and thickness of the remaining components, Adam creates shell and solid section properties accordingly. And just like the box, the materials defined in SolidWorks are maintained. The floor doesn't require section properties. Instead, Adam defines it as a rigid surface to help simplify the analysis. Additionally, since he's working with a simplified outer shell of the lid boss, he adds mass to account for the internal components. Moving on to connections, Adam creates a tie to represent the glue that holds the box together. For the interactions between components, he only needs two options: the global friction value and general contact. This eliminates the need to manually define faces or components that may or may not come into contact. Adam creates a clamp to hold the floor in place and gravity to apply a uniform force on the falling box and its contents. He specifies the mesh settings for the lid boss and foam, and updates the model to create the meshes all at once. With the mesh in place, Adam creates virtual accelerometers by creating groups in the mesh and associated output requests for the solver. Now he's ready to run the simulation. He can run it locally, or since his license includes the option to run the simulation on the cloud, he can free up his local resources and work on other projects while he waits. But he doesn't need to wait long. With additional tokens, he uses the high-performance compute power of the cloud to significantly reduce the solve time. During the solve, Adam checks on the progress and wonders if he missed anything in the setup. He investigates by loading the intermediate results, and sure enough, he forgot to apply an initial velocity. He reopens the status window to cancel the solve immediately. No need to save these results. Back in the scenario, Adam applies an initial velocity to the box and everything inside with a simple click and drag box selection. Now he's ready to run the simulation once more. With the simulation complete, Adam begins to investigate the results by animating the stress plot. The box is taking some damage, but the lid boss seems to be okay. On second thought, it looks like the gravity tube could be restrained. Comparing the acceleration plots, Adam sees that most of the shock is being absorbed by the packaging, so the changes for Eric should be minimal. To share the results, Adam configures lightweight settings to include animations of the displacements and stresses. Back in the dashboard, he attaches the simulation to the task and updates the progress for Eric. Eric views the 3D results in SOLIDWORKS, side by side with the source CAD model, making it much easier to interpret than static images or one-off animations. He has a plan for the design change, but before he takes action, he sees that Megan has commented on the task. The packaging cannot contain foam. To satisfy industry regulation, it must be made out of cardboard only. Eric revises the packaging model with an all-cardboard version, but he is uncertain how well it will perform. He reuses Adam's simulation by creating a new revision of it and replacing the referenced model with the new cardboard-only version. No need to start from scratch. The loads and boundary conditions are maintained, and Eric uses the assistant to help him with any updates. Reviewing the results couldn't be more rewarding. The lid boss isn't taking on any damage, the virtual accelerometers are reporting acceptable values, and Eric is getting proficient with their simulation tools. He heads back to SOLIDWORKS to update the validation task for Megan.
That was easy for Eric to bring in Adam as an external user and provide him access to the pertinent data and apps he needed. The explicit simulation let them measure the performance under real-world physics. Since all this work is done on the 3D Experience platform, the whole LidBoss team can dig into more results at any time. They can even resolve the scenarios themselves when necessary. Now we're starting to see the multidiscipline benefits of working from a single source of truth. With Megan's initial tasks being whittled away, this team still has some heavy lifting to do.